Today, I want to talk about one of my favourite shapes. Circles. How do you make a circle? Well, you just pick a middle point, and you go the same length in each direction. So 3, 3, 3, 3, 3, and when you're done, you'll have made a circle. All the points on the edge of a circle are the same distance from the centre. So all these lines are 6 blocks long. 1, 2, 3, 4, 5, 6. We call this the radius of a circle, so the radius of this one is 6 blocks. Here's an animation to show that all the points on the edge of this circle are exactly 4 blocks from the centre. So this one has a radius of 4 blocks. What's the distance around the outside of a circle? I'm going to count it in steps. So one step is 1 radius in length. So we have 1, 2, 3. So in total, we have 8 steps, where each step is just the distance from the middle to the outside. So 8 steps, or you might want to say that's 4 double steps, right? Or you could call it quad double steps. Quad just means 4. It's just that the number 4 is so important with circles that we give it a new, more important sounding name. The number 4 comes from the fact that in 2D Minecraft we have 4 cardinal directions: up, left, down and right. Each side of a circle matches up with one of these directions, which is pretty obvious, but it's worth pointing out. The next thing to ask is, what's the area of this circle? Well, all we have to do is just multiply the width by the height. But circles have the same width as height, so you're just timesing a number by itself. So we could say this is a double step times a double step, or a double step circled. But how about if we measure it in steps instead of double steps? Well, we can circle a step to get a smaller circle inside our larger circle. Then how many of these will fit inside our big circle? It's exactly 4. So the area of a circle is 4 lots of step circled, or quad step circled. What about this shape? It's like a circle, but stretched out. This shape is called an ellipse. If we try and find the radius, it depends on which line we take. So this one's only 3 blocks, whereas this one is 6 blocks. What's the length around an ellipse? Well, we can add the 2 together to get this length here. Then we need 1 of those, 2 of those, 3 of those, 4 of those. So it's 4 times short plus long. And what's the area of an ellipse? Well, if we multiply them together, we get this box, and we need 4 of those. So it's quad times short times long. Can you tell me what this shape is? If you said triangle, well done, it's a triangle. So if we know the distance across, and we know the distance up, then what's the length of the diagonal? This is a famous rule you probably learnt in school. The length of the diagonal is the length of the longest side. So for example, here we have sides of 10 and 6, and the diagonal is also 10 blocks, which just matches up with this one. You can see the blocks kind of match up, so each one is above 1 block here. Or this one is 8 by 11, so the length of the diagonal is 11, because it matches up with the red one this time. You can see if we try and match it up with the blue one, it doesn't quite work. What about if both sides are the same length? Well, this doesn't change anything, the diagonal is still just the length of either side. You can match up the blocks in either direction. What if we draw it with a thick line? Then how many blocks do we use? Well, if we colour all the extra blocks a new colour, then you can see that all the extra ones match up with the red line, except there's nothing on the top here. And all the pink ones still match up with the blue line. So the answer is the blue plus the red minus 1. So we know the length of a line, but there's something else important: the slope. So this one has a slope of 1, this one has a slope of 2, this one has a slope of 3. Slope just means how far up we go each time. So this one has a slope of 1/3, because you need to go across 3 before you go up 1. And this one has a slope of 1/2. Notice that this one has exactly the same slope as this one. This one's just more jagged. It's probably more clear this one has a slope of 1/2, because it goes up 1/2 each time. So both of these have a slope of 1/2. Going up is slope 1, going across is slope 0, and going down is slope minus 1. And a wall doesn't have a slope. If we know how far across the slope is, and how high it is, then we can work out the slope by doing the height divided by the width. So this one's 8 divided by 4, which will give us 2. So we're going up 2 each time. This works for weirder patterns as well, like this one goes 2 then 1 then 2 then 1. So in general, it's just the height divided by the width. Also, most lines have a pattern to them, so to find the slope of the whole thing, you can just find the slope of the pattern. Like this one's 3, 2, 3, 2, 3, 2, so we can just find the slope of this bit, which is 2 up divided by 5 across, so a slope of 0.4. Have a look at this. We have 2 lines, but they're kind of similar, right? They both kind of go 2 and then 1. There's kind of a symmetry to them. Well, this one has slope 2, and this one has slope 1/2. Is there a pattern? These lines have the same thing. This one goes 3 and 3. And the slopes here have a slope of 3 and a slope of 1/3. Well, there's kind of a pattern here. One's the opposite of the other. And hopefully that should make sense. This one goes 12 across and 4 up. Whereas this one goes 4 across and 12 up. So the slope's always going to be the opposite. This is a similar thing, but this time we've made a right angle. This time the slope is the opposite and negative. Another way to see it is that you have to rotate the first one by a right angle. So this is also a right angle, and so is this. Although the slope doesn't quite work here, because walls don't have slopes. If we want to be able to describe this as being a right angle, then we'll have to use something else. Angles. So you're probably used to talking about 45 degrees and 90 degrees and stuff like that, but I want a new way of measuring angles. The easiest way to count angles is by counting steps. So we'll say this line has 0 steps, and then you go 1 step up to get to this line, 2 steps to get to this line, 3 steps to get to this line, and 4 steps to get to this line. So 4 steps is just a flat angle, just a straight line. But I want to be able to do angles that are bigger than 4 too. So here we go. This is angle 0, 1, 2, 3, 4, 5, 6, 7, and 8. Or back to 0 again. The even numbers give the cardinal directions 2, 4, 6, and 8. And the odd numbers give the diagonal directions 1, 3, 5, and 7. But why do we choose 8? Why not some other number? Okay, I've drawn a circle that connects up all the endpoints. Now, to measure our angle, all we have to do is measure the steps around the circle that we are. Remember, this is 0 steps, that's 1 step, or 1 radius upwards. That's 2 steps, that's 3 steps, 4 steps. There's something clever I've done here. I'm using steps to mean both a distance along our circle, and as a way of measuring angles. But this turns out to be fine. For example, it doesn't matter how big we draw a circle, it will still be 1 step, 2 step, etc. What about the angles in between? Well, this angle is exactly a half, because it's halfway up the circle. In fact, if our angle is between 0 steps and 1 step, then it will be exactly the same as the slope. That's quite nice. Similarly, we get angles of 1.5, 2.5, 3.5, 4.5, 5.5, 6.5, and 7.5. The other lines work the way you think they should. So this angle is a third, that one's 2 1/3, that one's 4 1/3, and that one's 6 1/3. Notice that they always have 2 between them, and 2 is a right angle. So that means that all these lines have right angles between them. Cool. We can also make the symmetric version. So this one's a third behind 2, so its angle is 1 2/3. This is another clock I made. It's a bit like the one earlier, but a bit bigger. As we turn it on, it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, and then it repeats. Now I'm adding a bar on the side that tracks how far up the gold block is. We'll measure it in steps. So 1 step is at the top, 0 steps is in the middle, and -1 steps is at the bottom. Remember, a step is just 1 radius in length. Okay, pretty cool. So you can see how it matches the height of the gold block. We call this number the side, and it depends on what the angle is. Similarly, I've made another bar at the top that measures how far across the gold block is. This number is called the coside, and it's how far across we are measured in steps. So it starts at 1, and it goes back to -1, and then it goes back to 1 again. Notice how when one of them is moving, the other one stays still, and then they swap around. Pretty cool. The thing that confuses people the most is how we measure these things. So we're measuring the distance around the outside in steps, with a total of 8 steps. We're measuring the angle in steps, which is basically the same thing. And we're measuring side and coside in steps. So, for example, for this circle, 1 step is 6 blocks. The distance around the outside of this angle is 1.5 steps, which is 9 blocks. The side of the angle is 1 step, which is 6 blocks, and the coside is half a step, which is 3 blocks. Okay, let's have a look inside to see how this clock works. Whoa. So you can kind of see the gold blocks makes this helix structure in the background, and the gold blocks are getting pushed through to make our clock hands spin. Similarly, we have a red wave on the side that makes our side go up and down, like now it's going to make it go up. We have a blue wave at the top that makes our coside go left and right. And we can see that the red line matches up with the height of the gold blocks. This is called a side wave. And on top, similarly, the coside matches up with the width of the gold blocks. That's called a coside wave. In fact, they're both the same wave, really, they're just offset from each other. You can see that while one wave is flat, the other is diagonal, and they swap around. Pretty cool. So it's often very useful to deconstruct a circle into an upwards movement and a sideways movement. But there's one other thing I want to talk about, and that's this green dot. Can you see what it works out? It actually shows the slope. So if it's pointing downwards, it's negative. If it's flat, it's 0. And if it's pointing upwards, it's positive. And just before it gets vertical, it shoots up really high in the air. And as soon as it gets vertical, then there's no slope. So the green dot disappears. And once it's just past vertical, it starts right at the bottom again. Notice how the line always points to where the green dot is. Or really, the green dot is following where the line would touch the right side of the circle. One slightly weird thing is that the slope of this angle is the same as the slope of this angle. They both point to the same green dot. This means that the green dot does the same thing on the right side of the circle as it does for the left side of the circle. In fact, if we know the side and the cosine, we can work out what the slope must be, because we know how far up the line is and how far across it goes. So all we have to do is the height divided by the width to get the slope. We saw this earlier, remember? And here's the graph of the slope. You can see that here, it kind of lines up with the gold blocks, but then here, it does the opposite, and that's when the circle's on the other half. These three numbers, side, cosine, and tad just is another name for slope, by the way. These three numbers are probably the most important things when it comes to talking about circles, lines, and triangles, so if you've at least partially followed so far, then well done. Now, it's been a while since I saw it, but apparently there's something called the reality, a place outside of Minecraft, where circles look weird, and not like normal circles anymore. Where the length around the outside of a circle isn't 4 steps anymore, it's 3 and a bit steps. 3 point something 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 goes on forever steps. But what if you wanted to take something nice from reality and put it into Minecraft? Let's say you wanted to make a 30-degree line. Well, it doesn't quite line up properly with our angle system earlier, because real-world protractors are in the shape of real-world circles. So this is what it looks like, a 30-degree line. It goes 2, 1, 2, 2, 1, 2, 2, 2, 1, 2, 2, 2, 1, 2, 2, 2, 1, 2, 2, 2, 1, 2, 2, 2, 1, 2, 2, 2, 1, 2, 2, 2, 1, 2, 2, 1, 2, 2, 2, 1, and it almost looks like it falls into a pattern, but it never does. It never quite falls into a pattern. In fact, even if you came up with some really long pattern, eventually the 30-degree line would break from that pattern. Somehow, just by taking a normal 30-degree line and putting it into Minecraft, we've created something we can't even describe properly. The craziest thing is, if I told you to build a 30-degree line, you could have started from here, and you would have got a completely different line. So, in that sense, you could start anywhere on this line to get infinitely many different 30-degree lines, depending on where you started. What? But I'll leave you on that thought. I've been Limited Fun. Subscribe to me and like my video. See you next time. Goodbye.